Recording started.
Hello class, and welcome to the reverse mapping lecture. Now reverse mapping is a little bit different because what we're doing basically, we're given an end product, we're given a database, and we're going to work our way back toward an ER diagram from it. So we do this in cases where we want to better understand, basically when we need documentation about the database. Now if you work with, there are several tools, I guess probably Toad for Oracle. I know DB Visualizer and I know SQL Server Management Studio offer reverse mapping tools. They will basically generate an ER diagram for you from a database or a schema if you're an Oracle person. However, they can't provide constraints. They can't give you cardinality or participation because this is going to take a human touch. You're going to have to examine the relationships and figure out what best fits the situation at hand, depending on the data. Okay. So when we reverse map, it's kind of depends really on your perspective. Some people find it boring and some people find it fun. To me, it's more one of the more interesting areas. If you're the kind of person that likes jigsaw puzzles, Sudoku, anything like that, you may find this really fun here. So we've got a set of rules, okay? Kind of like with Sudoku or jigsaw puzzles, right? You start at the edges with a jigsaw puzzle. With Sudoku, you start at the crossroads of maybe two rows that have maximum numbers allowing you to minimize your choices for a first move. So just in the same vein, we have rules for reverse mapping here, okay? And this will make it a lot orderly and a lot more orderly and a lot easier to proceed. So first of all, what we want to do, I just kind of created a little fictitious database here for us to reverse map and to get an ER diagram from, okay? What we want to do, apply these rules in order, okay? Now, first of all, it's our strong entities. Everything else is going to kind of revolve around our strong entities. So we need to find these first, map them, draw them out. And I want you to do this with me by hand. Go ahead and get a sheet of paper. You have the rules up here, and they're also in the text. So if you could apply them, go ahead, go one step ahead of me, and then we'll see how you did. Okay, correct as necessary, but we're going to go one step at a time. We'll do it fairly slowly. Okay. So we want to look at our strong entities first, right? That's step number one here. Look for strong entities. Now, an entity has to be strong if it has a primary key, a non-composite primary key, right? It can't belong to anything else. It can't be a weak entity. It can't be. It's not going to turn out to be a relationship attribute. Nothing like that. Okay. So if a table has a one attribute key, it's strong. Okay. That's just a rule. All right. So I see that first, second, and third kind of fit that bill, right? Because I see I have A as the key for first, B as the key for second, C as the key for third. Now as far as the other table, there's kind of a bunch of junk in the key. I don't know, I have more than one attribute, so I'm not going there yet, right? Because if I look at mapping rule number one, or reverse mapping rule number one, it tells me to look for a one attribute key. So I know that first, second, and third are strong entities, and so I'm going to go ahead and draw them as such, right? So I'll go ahead and pull down.
Recording started.
And here we go. Okay, here are three entities. First, second, and third. We know they're strong because they have a primary key. It's the only thing in the primary key, so it can't be the case that it's a relationship attribute or a weak entity or anything like that. All right, so I got first with my key of A, non-key of F. Second with my key of B, non-key attributes of G and H. And then third with the key of C and non-key attributes I and J. So there, I've started. This is kind of the pivot, if you will, the crux of my database here, and I'm going to work around that. Okay. Now on to rule number two. Look for 1 to n or one partial to one full relationships. Okay. And they can also be relationship attributes. We'll cover that in a later number here, and I'll come back to this. Okay. But basically, what we're looking for is foreign keys from a strong entity. So, think back to mapping days when we did our regular mapping. If you shove a foreign key into another table, what does that tell you about the relationship there between those two tables or between those 2 entities? Okay. It tells you that that's either a 1 to n relationship, right? And the side that gets the foreign key is the N side, okay? Or it tells you it's a one partial to one full relationship. And the side that gets the key is which side? The partial, right? Okay? Now, it's probably more likely the case that it's a 1 to N relationship. That's kind of more common than, just a one partial to one full relationship. But if you have the data there in front of you, if you're looking at it and it makes more sense that it would be one partial to one full, then hey, have at it. Again, this is kind of one of these things, it's one of the reasons you can't have an automated program do reverse mapping fully for you. All right. So let's see, what do we have for foreign keys here? Now remember, a foreign key is a primary key of one table, kind of shoved into another table. So what we'll do is we'll look here, since we know these three are our strong entities right now. What we'll do is I'll look for A, for B, for C in any other table. Okay, so first is clear, first is void of these, second also, now third, aha! See, third has A in it. So that's going to be a foreign key from first. So since third is the side that gets the foreign key, it's either going to be the N side of a 1 to N relationship between first and third, or it's going to be the partial side of a partial full 1-1 relationship between first and third, right? Okay, now fourth, I see B there, but it's part of the key, so no, that's a different case. Same with fifth, it's part of the key, so I'm going to discard it for now. Oh, 6 has a bunch of these foreign keys in it, but you know what? It really doesn't fit the bill because they're also part of the foreign key, so I'm going to leave it for now. Same with 7th, really. So the only one that looks like it's touched by number 2 is going to be third, since it has a foreign key from from a strong entity in it. It's the primary key of a strong entity. All right. So what we'll do is we'll create a little relationship here between first and third. So 1 to N, or one partial, one full, but I'm thinking 1 to N. That's probably more likely to be the case. And since we don't have the data here in front of us, I'm just going to say it's 1 to N, okay, since it's the most likely case. So we'll run on over to Diane and show what that looks like.
Recording started.
All right, so this is what it's going to look like. And actually, it should be okay. Now, here's something that you may or may not have caught. I didn't. So when we looked, let's see here. Yeah, there we go. So third, we have C, I, J, and A. We deduced that A was a foreign key from first. Kind of has to be because we see that it's a primary key at first. I had forgotten to put the A attribute here, so I apologize. There it is, okay? But now, since we know that that's just a primary key that came over from first here in third, we know that's not a real attribute. That's kind of a pseudo attribute, if you will, on third, so get rid of it. We know it's not there. We know it's in first. We know it belongs to first. It's the primary key of first. So A should have been on third, and then as soon as we realized that it was a foreign key that came over from first, that it came over from first, we axe it. Get it out of the way. All right. So that's step number 2. All right. So we got our strong entities, and we found, what may be a one partial, one full, but we'll say is a 1 to N relationship. I'm not going to make any assumptions here about the cardinality. If we're 1 to N, we're 1 to N. I don't have the data in front of me, so I can't tell what makes the most sense. Okay, so we're just going to go with 1 to N for now, partial. All right. Now, step number 3, look for a weak entity. Now, remember, a weak entity has a partial key, right? Okay, so what's the primary key of a weak entity? It's going to be the partial key plus the key of the owner, the strong entity, correct? Right? Okay, and it'll probably have other attributes as well. So I remember we had, what was the example we had? We had an example of pet name plus, I think, owner social security number we saw. All right, so that's the pet name is a partial key. The owner social security number combined with pet name makes up the entire primary key, because only then do you have enough data to be uniquely identifiable, right? And then there was also something like pet breed, which would be the non-key attribute. All right, so this makes sense then if we look at it this way. So what we're doing, we're looking for a primary key composed of foreign key, okay, plus the partial key. Basically plus an attribute that is part of the key that belongs to this table and no other table, okay, and really any other attributes, any other attributes on top of that. So that'll probably tell us if this is a weak entity. Now, notice I didn't say a foreign key from a strong entity, because weak entities can own other weak entities, so I'm not going to say, an FK from a strong entity. It can be an FK from a weak entity, okay, just heads up. So what we'll do here, we'll look for, foreign key plus, we'll look for a composite key. One of those is going to be a primary key from another table, and one of those attributes is also just going to be unique to this table. So let's see. All right, here we go. D and B, that kind of fits the bill, but you know what? It doesn't have any other attributes. It does have a primary key from a strong entity. It does have its own entity, and they both form the key, the composite key, but it doesn't have any other attributes. So that doesn't really fit the bill here. Okay, let's see here. Aha! Here we go. Look at this. Fifth has a primary key from second, and I don't see E anywhere else, at least not in any kind of strong table or anything like that. You know what? This is probably a weak entity. So it looks like fifth is going to belong to second, right? So in other words, E is probably a partial key. B is going to be the key from second, okay, its owner entity, and then L is just going to be extra data, okay? So there's one there. Let's see. Sixth, no, all I have are foreign keys here. Okay, that's a different case. And the same here, really, okay? All right, so we'll go ahead and proceed. What we'll do is we'll make fifth the weak entity coming off of second, which is going to be the strong entity. All right, so we're going to pull die up and we'll see how that looks.
Recording started.
And voila, there it is. Okay, so I have second as my strong entity and fifth as my weak entity. Second is the owner of fifth. I just kind of call the relationship, SF for second, fifth, because I don't know what it's called. In the database, we might be able to make sense out of it and give it a meaningful verb, but here we don't really have that info, okay? Now, fifth has E, which you said was a weak key, the partial key, rather, and L as the non-key attribute. Remember, B is going to be the owner's primary key, so we don't put B on fifth, okay? Now, remember, these are usually 1 to N, and the weak entity is going to need full participation. So this is usually what it looks like, okay? So far we have these two. All right, so we've identified a weak entity, okay? Now, what's the next step say? Aha, this is fun. All right, we look for multi-valued attributes. Now, multi-valued attributes, remember, for mapping purposes, what we do with multi-valued attributes, we excise that multi-valued attribute. We create a new table. The new table is going to be the primary key of the entity on which the multi-valued attribute resided, plus the multi-valued attribute itself. Okay? So it kind of makes sense what we see here. If we see a foreign key from a strong entity and a local attribute, basically a composite primary key composed of foreign key from a strong entity and one attribute, okay? And we see no other attributes. We see it's all key, and that key consists of a foreign key and something particular to that table, then we know it's probably a multi-valued attribute. And we'll know to put it on the attribute that gave it an FK. Basically, the attribute that has the PK corresponding to the FK in the table, in the mapping table, right? So let's look. What we'll do right now is we'll look for a table with a foreign key and one other piece of data that makes up the key. Okay, no. Okay, here's a table that's all key. Let's see. Okay, I have a foreign key from a strong entity from second. Okay, and Ooh, yes. Here we go. I have the other part of the key is specific to this table. Okay? So it's all key. It has a foreign key and another piece of data specific to this table that makes up the key. So this is probably a multi-valued attribute, okay? So I think we've identified one here. There's this fourth. No, because the other ones aren't all key, okay? So it looks like fourth is the only multi-valued attribute we have, okay? And it looks like it came from second, all right? So we will put D, which is the multi-valued attribute part, right, on the entity second, okay? So we'll jump over to dia and see what that looks like.
Recording started.
And there it is. So I've got a multi-valued attribute D on second, okay? So that takes care of that table 4. All right, so we've identified one MVA. So what's next? All right, next mapping rule. So we'll check for M-to-N or one-full to one-full relationship. Okay, remember, kind of similar, kind of in the same vein as MVAs, what you do with M-to-N or one-full to one-full relationships. There are other things you can do with one-full to one-full, but what I prefer doing, so we don't have any null values here, we excise, well, we don't excise, we create a new mapping table, okay? And the new mapping table is going to consist of the primary key of each of these entities, and that's it, right? Or we could have other attributes, okay? So basically what we're going to look for is keys from 2 tables, all right? So
Recording started.
and by the way, this is optional, plus other attributes is kind of optional, okay? So let's see here, do we have anything belonging to, with keys belonging to 2 different tables? No, that was our week. No, that's all key. Ooh, that's kind of interesting, but it's not really 2 tables, right? It's 3 different tables. You know, the keys from 3 different tables. Aha, here we go. Okay. 7th has A, which is a primary key from first. B, which is a primary key from second. And some other junk there. So, yeah, that fits the bill here. Oops, I didn't mean to do that. Okay, so it looks like we have an M-to-N relationship, and we have O is probably a relationship attribute there, so that'll probably be an attribute coming off of that relationship diamond. Okay, now optionally, if we didn't have O there, just the fact that we have primary keys from 2 different entities would still probably indicate an M-to-N mapping. So we would probably be able to say, yeah, first, second is M to N. Okay, we could probably say we have a relationship there, but since we have an O there, it's an even stronger indication of an M to N relationship, and the O is a relationship attribute. You know, we stick O on the relationship because it doesn't really belong particularly to either of the entities. In other words, it's going to take both of the entities to identify it. It's kind of like we had, if I'm not mistaken, we had dorm number. We had something like dorm number on the student residence building relationship, okay? Or we could have grade on a student course relationship, right? Because a student gets a grade in a course, you know, a student has a room in a building, okay? So what we'll do is we'll go ahead and make a new end-to-end relationship and say, you know, between first and second, we'll stick O on that relationship. So let's go ahead and we'll jump over to dia and see what that looks like.
Recording started.
And voila, there it is. So we have our end-to-end relationship between first and second. We have a relationship attribute O. So, you know, O kind of depends on first and second really to identify it. So there we go. Our diagram's kind of coming together, right? And hey, we're almost, we're getting kind of toward the end here. Okay. So for B, what we want to do, check for what you call n-ary relationship. So that's basically 3, you know, ternary or beyond, right? So what we're going to look for is a bunch of foreign keys, 3 or more, right? Okay. Now, these particular foreign keys are going to make up the primary key, right? And you can also have other attributes optionally, right? It doesn't have to be, but you can, okay? So let's see if we have a whole bunch of key in one of these tables. Yeah, okay. All right, strong, strong, strong. Hey, it looks like we have a winner here, okay? It looks like we have a relationship between third, second, and first, right? Now, again, we didn't have to have M here, okay? If we didn't, we'd probably still say there's some kind of relationship between first, second, and third. But the fact that we do even solidifies it more, and we can say M is probably a relationship attribute on all three of these, okay? It's kind of like, I think we had a three-way relationship that was in the book. It was something like product, supplier, and consumer, and the relationship attribute there was price, right? Because it kind of needed all three to make sense. If I'm not mistaken. I may be butchering that, but it's something similar. But anyways, you get the idea, okay? So in other words, the M attribute here needs to rely on all three to identify it, okay? It kind of fits with all three of these. All right, so what we'll do, we'll draw a three-way relationship. They'll all go into one diamond between first, second, and third, and we'll draw a little attribute off that diamond for M. Okay, so that's just a piece of data, a non-key piece of data. All right, so we'll go ahead and jump over to Dia and see what that looks like.
Recording started.
And there we go. Now don't panic. You know, if you were paying attention before, you'll notice that this diagram's a bit different than it was before. All I did was rearrange because it was kind of cramping my style. I couldn't fit everything on the page. So if you look closely, you'll see it's the same exact relationship. I just kind of changed it around a little bit, kind of like playing Tetris or whatever with it. So what I've done is I've added this first, second, third relationship here. Okay. I guess the fact that first and second already have a relationship doesn't really preclude them from having a different relationship in a different context, right, between these three relationships. So I called it FSD, first, second, third. Okay. You know, I have my different cardinalities here. I think the book says something like, you know, M to N to M, or maybe it calls it N to M to N. I think they just did it that way so to not throw a whole lot of variables at you, but I just called this X, this cardinality X, to point out the fact that, you know, just because we have two M's, if the book calls it M to N to M, it doesn't necessarily mean that, you know, two of the attributes are going to have the same cardinality, right? So these could be three completely different independent cardinalities. So there you go. You know, that wasn't too bad, right? It took us a few minutes, but, you know, once you get out and you scratch it on paper, do an example or two, you're good to go here, right? You just pretty much apply the rules and just take the time going through the steps, make sure you don't miss anything, and kind of look at it all after the fact, make sure it makes sense. Have the mapping rules in your head, make sure that what you're doing makes sense to you, and that's really about all there is to this. That's all I've got to say about that, as, you know, Forrest Gump says. So, all right, well, I hope this was informative, good lecture for you. So, all right, have at it. See you in the next lecture.